Welcome to part 2 of the restaurant problem. I am going to calculate the power and the type 2 error of this situation. So basically what we have right now is I want to open a restaurant, and as long as the people living near and around the restaurant have a mean income of $85,000 or more, I feel that the restaurant can be supported. So the first step is to label my null hypothesis. So this is my null, and I have to find my standard deviation. I know that I'm approximately normal with a mean of 85,000, and now I have to find my standard deviation. So we're going to use the population standard deviation divided by the sample size, and 5,000 divided by the square root of 50 gives me $707.11. So that is how I am going to make my spread. And doing this, I would label this with 82,878.67, 83585.18 should be 78. This would be 84292.89, and we have our 85,000 in the middle. Then I have 85707.11, 86414.22, and finally 87121.33. All right, so that is my null hypothesis labeled. Now I want to very carefully place my alternative hypothesis. And the thing I should have mentioned at the beginning is that I knew the null hypothesis was going to start over to the left because this is a greater than problem, and I'm looking at my alternative hypothesis being a greater than situation. So I am going to temporarily place a line where I think that 87,000 would go because that is my alternative hypothesis. So this is basically 86 and a half, and this is almost 80. I'm going to put 87 about right here. And with that knowledge, I'm going to take my alternative graph and make sure that the mean is going right through where I think the 87,000 is. So now that I have that placed, I can temporarily remove that line and put in my numbers for this. 84878.67, 85585.78, 86292.89. This is my 87,000. And then I have 87707.11, 88414.22, and finally 89121.33. So I have my X scales and my Z scales all labeled. And I'm actually now finally ready to start the problem. I will write that this is my alternative hypothesis. And I think I will put that just up in the top of the normal curve. Okay, I want type 1 error to only be 1%. So the key factor is that's where I start. I know that at 2, I have 2.5% below me. At 3 standard deviations out on the standard normal curve, the Z curve, I have 0.0015 or 0.15%. So I'm going to say that 1% is maybe somewhere right around that point. Color this in green. That is my type 1 error. It is my alpha, and it equals 0.01, which allows me to say that the other side of this line is my confidence, which is a term that I've kind of coined for this, That would be 1 minus 0.01, which is 0.99. So I'm 99% confident that I can find the mean income to be 85 grand or less, if in fact that's the case. All right, so now I have to find the X bar score and the Z score located at this cutoff. I know that Z is going to be 2 point something, and X better be 86 something. So to find that, I'm going to have to look up 0.01 on my table. And when I use my table to do that, I find that the probability that Z is less than, I find 2.33 to be the answer for if I look up 0.9900. If I'm looking at 0.01, I get negative 2.33. So since I'm over on this side of the graph, I need the positive. Now I have to undo this situation to find my X bar. So I know that 2.33 is equal to the X bar that I'm looking for minus the mean of 85 grand divided by the standard deviation, which I found to be 70711. So if I multiply 2.33 times 70711 and add on 85 grand, I get my X bar to equal 86,647.57. 86,647.57. That is my score that would cause me to have some problems for myself if I had a mean of 86,647.57. That is the key value that I needed to find, because I'm going to now take that key value and I am going to take this and I am going to move it down to my alternative hypothesis. So I know, let's see if I can get this to work. I know that this purple line represents X bar equal to 866.47.57. So let me make that a little bit nicer after all that. X bar is 86,647 and 57 cents. Okay. At this point, remembering what my teacher told me, that beta is always on the other side of this very important line from alpha. This is my beta, and that's the chance I have of basically losing a good location. And this is my power, and that's the chance I have of finding that the population actually can support my restaurant, when in fact it is true that they can support my restaurant. Okay, now I'm going to do a frontwards problem. So we did an undo it problem to get our X bar, and now I want to, if I'm looking for beta, I want to find the probability, which is also, by the way, a type 2 error. Should put that up here. Find the probability that I get a sample less than 86,647.57 when I'm in the alternative world. So the only reason to talk about beta and power is because I'm in the alternative hypothesis. In order to figure out that, I need a z, which I see is going to be just negative 0 point something, and the resulting probability will be my answer. So let's standardize this score, 86,647.57 versus the mean of 87,000 divided by the standard deviation of the original, which was 70711. And doing the math for this z-score, I come up with a negative 0.498, so I'm going to use negative 0.50. Now I have to go look up in the table, and when I look that up in the table, I get approximately 0.3085. That is my type 2 error probability. And if I want to now find my power, that's easy enough done. The probability that X bar is greater than 86,647.57 cents is approximately the probability that Z score is greater than negative 0.05 or negative 0.50, and that is approximately 1 minus 3085, which is going to be 6915. And that is my power. So it took all of that work to get to these two answers. And I am going to be sufficiently happy with this because right now I only have a 1% chance of opening up a restaurant and losing money. That's my type 1 error.